there are two ways that we can solve these equations. You can either get a common denominator throughout or eliminate the denominators completely. Now, we're gonna do this problem both ways, and then whichever way you prefer, we'll like kind of keep doing that, or we can just keep alternating. So,
will all of us like prefer different ones, or will we all agree on one?
You know, that we might disagree, and then in that case we will alternate. All right,
What kind of question was that?
That's a good question.
Before we solve, we are going to state the restrictions.
Oh man.
The restrictions are important when you're solving equations because they will tell you if a solution or solutions are extraneous. So the very first thing you're going to do is observe the denominators. You're going to set them all equal to 0 and solve, and those are your restrictions.
It's 3 negative.
Restriction enzymes. Good voice. Yeah, I kind of know
Now
how to do it.
you have 3 denominators. Okay.
My heel.
If you set this equal to 0, you get x equals 3. If you set this equal to 0, you get x equals negative 3. And if you set this equal to 0, you get x equals positive and negative 3, which are included in those two statements. So, x is not allowed to be 3 or negative 3. If x is 3 or negative 3, that gives us a denominator of 0, which we can't have because it's math and we can't divide by 0. Okay, so that means if we get solutions, x equals 3 or x equals negative 3, those are going to be extraneous. Now, if you have only one solution and it's extraneous, that means you have no solution. If you have 2 solutions and one is extraneous, then you just cross one out. You could have 2 solutions and neither is extraneous, or you could just have one solution and it's not extraneous. So you can get 1 solution, 2 solutions, no solution, whatever. Now, I'm going to do method 1, finding a common denominator. Common denominator.
When do you ever have to use a common numerator?
That's not
Never.
I know. Okay.
So when you're finding a common denominator, the first thing you want to do is factor if possible. So we can factor x squared minus 9, that's a difference of squares, to x plus 3, x minus 3. And that just tells us that that denominator has both the x plus 3 and the x minus 3, which means our common denominator is this denominator. We need both the x plus 3 and the x minus 3. Put the computer away. So, if this fraction has a denominator of x minus 3, I need to multiply it by x plus 3 so that it has both. And if this fraction has a denominator of x plus 3, I need to multiply it by x minus 3. Now, the final fraction has both, so I don't need to multiply that by anything because it already has the denominator x plus 3 and x minus 3. So this fraction, when I distribute the x, becomes x squared plus 3x over x minus 3x plus 3 plus this fraction is going to become x squared minus 3x.
There was one question on the quiz yesterday that like had I think it was like number 4.
Hey, don't tell me the answers. I have to make it
Yeah,
up.
he,
No, I didn't say the answer. I just said there's not a number.
Yeah,
It was just
numbers.
like, it was just weird. I don't even know.
Alright, so just distribute, you've created new numerators. Now, the whole purpose of finding a common denominator is what? Why do we do it?
So then you
To
could like
add.
add and subtract.
So we can add. So we're going to add our numerators. So we're going to add these numerators, and that gives me 2x squared. 3x plus negative 3x is 0.
0.
So my new numerator is 2x squared, and that's all over my common denominator.
Oh my god, guys, the answer is 1. Right.
Probably.
Are we solving for x?
Now we're going to solve for y.
I literally just don't. I
Well, don't you
like
have
any
to
of
don't you have
it.
to solve for y before you find x?
Alright, so now, do you see how the denominators are the same and the numerators are not the same?
Yeah.
Yes.
So if I had written over here, like, box over 5 equals 3 over 5, what is box?
3.
Right.
Something.
That's the one-to-one property. If you
Yes.
have something equals
Oh, so
something.
then x is 0.
No, X is
no.
definitely 1. X
Yeah.
is definitely not 0.
So what that means, though, is that if these both have the same denominator, that we can take the numerators and set those equal to each other. Because the numerators have to be equal. This has to be equal to 2 in order for that equation to make sense.
So what if it doesn't? Is it no solution?
Well, you make it equal.
Like it's automatic.
I guess if this was like a
Like, what if
3,
it doesn't
yeah.
work out?
So if this was like a 3 over this and this was a 2 over this, then
Yeah.
that would be no solution.
Yes. Okay,
Yes.
cool. That's what I meant.
Yeah.
Uh,
All right.
But
So
if you still look at it,
Ah!
it should just be a really bad number.
in order to solve, we're gonna divide by 2. Okay. And then we'll square root both sides.
Well, you gotta split both sides.
Isn't that like
X
I?
squared
Oh my
No,
god,
it's
it's
not
plus or minus
negative.
1. I'm literally done.
plus or minus 1.
I'm literally done.
That's so awkward.
Now, after you get your answer, you're just gonna check with your restrictions and just make sure that the answers you got aren't also restrictions. So are they?
No.
No. So we're good.
So we just found the common denominator.
Yeah.
If it were 3, wouldn't it just be a really bad number? But you can still get 2.
Not necessarily.
Square root of 3 divided by.
Oh yeah, you can get an irrational answer.
Oh man.
Irrational.
That's gross.
It doesn't have to be rational, it just has to exist. If you get an imaginary, that's like a no solution type of situation, like a no real solution. Alright, so that's the finding the common denominator method. The other way is to eliminate your denominators. Eliminate.
Oh yeah, that's probably a little
I'm
easier.
probably gonna like this one better.
Yeah.
eliminate.
Sounds like simplification, and that's so easy.
Right.
I don't know that this is necessarily easier.
Which one do you think is easier?
I do it my own way.
Wait, then show us your way.
Well, show me your way.
Well, I just do it in my head.
Oh, well
Then
that's
how-
not.
Hey,
That's
so
very
you should be able
uncalled
to
for.
do it
Help us
too.
do it in our head. How do you do it in your head?
Gotta
Do you not? Do you
have to crawl before you walk. All right.
do you common denominator
I
it
run,
in your head,
okay?
or do you?
Alright, so in order to eliminate the denominators, so let me just kind of give you a side note example. If I had like x over 3 plus 1 over 2 equals 4. In order to eliminate the denominators completely, you can multiply by what would have been your common denominator. The thing that the denominators all go into. So what is something that these denominators go into?
6.
6.
Something.
So if you multiply these all by 6, this would become 2x, this would become 3, and this would become 24. And
You're
it
not
gets rid of
multiplying
the
the 3 by
denominators.
6?
No, it's
6 over 1 times x over 3 is 6x over 3, which is 2x.
Oh, I was looking at it like you distribute the 6 to the top and bottom.
No, no, you're
Total
multiplying
lie.
6
No, because
times
the
a
3 and the
fraction.
2 cancel out to a 1.
Alright, so we can use that method for this question. So you're multiplying by what would have been the common denominator, also known as the least common multiple, like the thing that is the smallest thing that your denominators will go into. So in this case, it would have been x minus 3, x plus 3 that the denominators would have gone in, like, or that would have been the common denominator. So you would take this entire equation and you'd multiply it by x minus 3, x plus 3.
Oh my god, that's nasty.
Now, I'm going to show you like what this would look like with each individual fraction. So you would have x over x minus 3, and you would be multiplying that by x minus 3, x plus 3.
Yeah, I don't like this one.
I hate this.
Well, eventually you can do this in your head, and it's easier. And so then, same thing here. We'll multiply this by
you're
x
using
minus
gator
3.
colors.
I'm not doing that on purpose. And then here we have 2 over these guys times x minus 3, x plus 3. Okay, so what happens is, if you just take a look at this first fraction,
I'm so stupid.
okay,
Yeah, you are.
what happens is,
X minus 3.
these cancel, and you're left with x times x plus 3 over 1. Eliminates the denominator. In the second batch, these cancel, and you're left with x
I mean,
minus
that
3.
kinda is easier.
And then these cancel, and you're left with 2. Now, when you distribute all this out and simplify, that's what brings us here, right? So you get x squared plus 3x plus x squared minus 3x, and then you combine, and we're back to here. So it's just a different way of thinking about it. Involves like canceling, like working on our multiplying fractions or other.
Yeah.
But eventually you get the same answer. If you're not good with fractions in general, this is not the way for you. Like if you're not good at doing this in your head, don't do it that way. Okay, if you are, then maybe you do want to do it that way because it might make it takes less writing, okay? But if you're not good at doing fractions in your head, that's going to take you longer because you're going to have to write this out and really think about
If you
it.
got a calculator.
I can do this in my head and it takes me less time. So it's all just about what your strengths are.
So hold on.
How'd you do it?
So you can cross out the top and the bottom on that first part, and now you just got x times x plus 3, and you get x squared, or 3x, or x squared plus 3, x, and then
And so here I cancel
overall,
these.
yeah.
So you
Same
multiply
thing,
these guys
but just
together.
x squared minus 3x.
And then here they both cancel and you're just left with 2.
Oh yeah, that's easy.
You sure?
There's nothing
Yeah.
wrong with that.
So yeah, just like factor real quick. This factors 2x plus 2, x plus 1. And if it's not those two things, then you might need like an extra factor. Like so if this isn't these two, then that means your common denominator would be 3 binomials. Or perhaps 2 binomials and like an extra x.
We leave the first one right, and then the other two. We just
Wait,
multiply.
real quick. Restrictions.
Oh,
X cannot be -2 or -1. Just want to make sure that you don't forget about it. Often you'll just kind of go through the question and then forget. Those are important. All right, so do you want to find the common denominator?
Indubitably.
Okay, so common denominator, I need to multiply possibly all 3 fractions, maybe just 1 fraction, maybe 2 fractions, I don't know. But I'm gonna multiply by something to get them to be the same denominator. So, since I factored this, I can see that every fraction has either an x plus 2 or an x plus 1. Okay, and nothing else, there's just those two. So, if this fraction has x plus 2, then it needs x plus 1. And if this fraction has x plus 1, then it needs x plus 2. Okay. And so, this fraction didn't need anything. So you have x minus 1 over your common denominator.
You know what's funny? This actually makes not too bad of a sense.
it's plus, not equals. Over the x minus 1 over x plus 2.
Oh, thanks. I put 3 equal to
Yeah.
That's obnoxious. Alright, so then up here we're gonna multiply and we get 2x squared plus 2x. Up here we're gonna multiply. Now when you multiply up here, you're multiplying a binomial times a binomial, which means you have to do what?
Foil.
Yeah.
I kind
Foil.
of just like
Oh,
left
that's
it like
right,
that
bro.
though.
Oh.
So, well, eventually you're gonna have to multiply them. So FOIL, you get x squared plus 2x minus 1x minus 2. Now, that's another thing I can do in my head that in theory, at this point in your Algebra 2 career, you should be able to do in your head too.
I sort of.
If you're not good at foiling in your head and you're like, you don't have homework one day for me, that's something that you can work on, okay? You don't need me to work on foiling in your head. You can literally just make up any 2 binomials and just work on that. It's kind of like doing multiplication flashcards. Like you did that when you were in 2nd grade. Foiling in your head is something that you can do on your own time to get your skills better. I promise it's going to help you so much more when you get to pre-calc and beyond. And Mr. Hill's probably going to expect you to know how to do that. So this numerator is x squared plus x minus 2. Now, you can either combine these, or if you want, once you have that common denominator, you can just get rid of it. As long as all your fractions have the common denominator, you don't need it anymore. Okay,
So
Why?
he's gone. That's that one-to-one property. If all the denominators are the same, we can get rid of them because all the numerators are the same. Or you could multiply by that denominator and it would cancel out in every single fraction, going away completely. The reason we need the denominators is because we need these restrictions. So we can't just ignore them. Also, we needed to find a common denominator to get to this point. Now I can combine this with this. You want to be careful. If this is a plus sign, you can just combine. But if it's a minus sign, you have to distribute. But it's not, it's a plus sign, so it doesn't matter. So I'm gonna get 2x squared. When I combine my x's, I get plus 3x, and then there's just a negative 1 left. This is, we have quadratic terms in here and they don't necessarily cancel out. We can't use the square root property. So we need to get everything set equal to 0. So I'm gonna subtract x squared, subtract x, and add 2. So this should look kind of familiar. We've done questions like this before in previous sections. So this gives me x squared plus 2x plus 1 equals 0. So I got a quadratic trinomial, which means I either want to factor, complete the square, or quadratic formula. What do you want to do?
Factor.
Okay.
X plus 1, x plus 1.
Yeah. Okay, so factor, set your factors equal to 0, and you get x equals negative 1, twice.
Do we need to write that it's twice, or do you just
Nah, it's whatever. The last thing you're going to do is just check your restrictions. Do you see how our answer is a restriction?
Yeah.
And it was the only answer. So if our only answer is a restriction, what is our answer?
No solution.
Right, so we're going to say x equals negative 1, but it can't be negative 1, therefore we have no solution. Now, if you don't go back and check, you think you have an answer and it's not really an answer, it's extraneous. Sometimes we do math to get through a question and we are creating answers using an algorithm that doesn't necessarily apply to our question. And that's what causes extraneous solutions.
Can I do like each way, like whenever I want? Like it doesn't matter if I.
Yeah. This fraction gets multiplied by x plus 1, and this fraction gets multiplied also by x plus 1. So this is the first one we've done where each fraction is getting multiplied by something. So keep in mind, all 3 fractions, maybe you'd need to multiply them all by something, or it could just be 1. So up here, this numerator becomes x squared plus 4x. This numerator is going to become 3x plus 3. And then this numerator, when you FOIL, becomes x squared plus 4x plus 3. Now, in between, we had a plus sign, an equal sign, and some denominators.
Wait a second.
I just like got rid of my denominators
Yeah.
completely, and the very like, if you look at my like
That's
work,
fine.
there's nothing even there.
Right,
It's so bad.
that's good. Kill them all. All right, so then at this point,
Kill a moth.
you would combine your numerators. So that gives me x squared plus 7x plus 3. And then you would put that over your common denominator. And this would be equal to this guy over your common denominator. So you can get rid of the denominators and you're left with this. When you solve this, your x squareds will cancel when you subtract x squared from both sides. Your 3's will cancel when you subtract 3 from both sides. And so you get 7x equals 4x, which is a little awkward, but this is an x linear term, this is a linear term. So you would want to combine them. So you would want to subtract 4x from both sides and get 3x equals 0. And then you divide by 3 and get x equals 0, which isn't one of the restrictions because your restrictions are -1 and -4. So that's your answer.
So, how much do I have to show in order to know? Because I feel like the way I do it, you're just gonna be like, you didn't even show that you had a denominator in the first place. But I
Well,
feel
you
like-
all see the original question.
Emma, we get it, you're smart.
You
No,
don't
I
have to
just
show
mean, like,
too
the-
much. Here's the minimum. You can show this,
Jeff is
and
back.
you can show this,
Oh, okay, that's.
and then some version of whatever's left. That? Yeah, I'd say that's the minimum.
Yeah.
Right?
I got 0.
Sorry, Jeff.
Yes,
Thank
that's
you.
right.
Mr. Up, I got 0.
Now, if you choose
That's
to
right.
eliminate your denominators,
You got a 0?
Did you really? Did you really get 0?
No, I just copied down what you wrote.
you would multiply by x plus 1 and x plus 4. That would be your least common multiple. In this first fraction, the x plus 1's cancel, and you just are left with x plus 4. In the second fraction, the x plus 4's cancel, and you're left with x plus 1. And then in the last fraction, the x plus 4's cancel, and you're left with x plus 1. And then you essentially do what we already did, and you get your answer. Yeah. You can solve by finding a common denominator or eliminating the denominator, or what's the easiest way
Cancel.
Head math.
is to cross multiply. If you have fraction equals fraction in any circumstance, you can
Why
cross
did it be
multiply.
5/6?
Because you're multiplying. So you multiply your x plus 2's together?
Yeah, but when did the x plus 2 and x plus 2 cancel out?
X squared.
No, because you're multiplying.
Trust me.
So x plus 2 times x plus 2, and then 5 times 6, cross multiply. You don't, you don't have to do it this way. But this is the fastest way.
So for like the U try one, would you cross multiply the whole like x squared
Mhm.
minus 225 and then like simplify it and then cancel the x minus 5?
Well, so it's up to you. After you cross multiply, it's up to you how you want to solve what's remaining. Now, depending on what's remaining, you might want to solve a certain way. For us, this is a perfect square, so we can just go straight up,
Oh,
square root both sides,
okay.
because it's something squared equals something, so we can use the square root property. Now, another way you can do it is to FOIL out the x plus 2 squared, get everything to one side, and use the quadratic formula.
Yeah, no, I'll pass.
Yeah. Just don't forget your plus or minus, and then also, if it's simplifiable, you want to simplify. So for
I don't
example,
think it is it?
No.
30 is 10 and 3,
Yeah.
and this is 2 and 5.
So the answer's false.
That doesn't simplify.
So just be -2 plus or minus square root of 30.
Yeah.
And so yeah, so then the last step is to just subtract 2. It does say to check your solutions. All you're checking is to make sure that your answers are not extraneous per the restrictions. So at the very beginning, your only restriction comes from that factor, and it's just that x can't be -2. So, not a restriction. This is also like the domain. If this was a function, if this was like equal to f of x, that would be your domain. X cannot equal -2, so just kind of reminding you about domain and range and all of that. All right, so there we go. That's technically 2 answers. You got -2 plus root 30. You got -2 minus root 30. So your restrictions from here are plus or minus 5, because if you set this equal to 0, you get +5 and -5. So it's not just regular 5, it's also -5. Now when you cross multiply, 1 times x squared minus 25 is x squared minus 25. And then x times x minus 5 is going to be x squared minus 5x. So these would cancel when you subtract x squared from both sides. And then you would divide by -5 and get x equals 5. But that's one of our restrictions, so we have no solution.
Okay, I have a really dumb question, but this is something that I've actually genuinely been confused about my whole life. How do you know when you cross multiply which problem goes to which
Doesn't
side?
matter.
It really doesn't matter.
It really doesn't
I
matter.
really thought it mattered for like my whole
No.
life, and I always got so scared I'd get it wrong.
No, yeah, that part doesn't matter.
Okay, Miss Wright, ready?
No.
1750
Okay.
total.
The next
6
two
months,
that we
what is
will
the interest
do
rate?
not have numbers.
What is that?
Can't see.
So when you're doing the same
Hmm.
kind of properties,
Yeah, he's back.
but you can't get an answer like x equals 5. So usually they're like formulas, and we're trying to solve for a particular letter. So in this one we're solving for b. Now b is also squared, so we just have to keep that in mind. We're gonna start the same way we started the other questions. We're gonna start by cross multiplying. So when you multiply
Yeah.
these. Now, the reason we're cross multiplying is because the letter that we are trying to solve for is in the denominator.
So,
You can't solve for a letter if it's in the denominator. You need it to be in the numerator at some point.
do we put them in like alphabetical order or?
Usually I try to. This one's got a lot of letters.
Yeah, what the
But yeah, usually I try to put it in alphabetical order. But then also the numbers come first. So numbers first, then letters. So multiplying the other way, we would get 2mv if you want to put that in alphabetical
Oh
order.
dang, I put 2VM.
Try to put it in alphabetical order. If it's an equation that represents like a formula, then it's usually in a particular order that, like physics formulas, like they're in a certain order, not necessarily alphabetical. If it's just random letters, then in algebra we put it in alphabetical order to give it some sort of organization. So we're like simplifying like you don't write x2, you write 2x, because this looks like times 2 and it's confusing. So for the sake of algebra, we put it in alphabetical order, but if it's something else, like a formula, then it doesn't necessarily have to be in alphabetical order, it's
Formula.
probably in some other order. So like,
Why does this actually look like a formula?
density equals mass over, I guess that's not a good example. Not enough letters.
Density equals heart with
If you wanted to solve for mass, you would multiply by v.
Time
So
equals
you could put
velocity
it in
over
alphabetical
distance.
order, or you could not, because it's not necessarily like representing. It's representing a formula, not like just plain old algebra. So anywho, we are going to solve this for b. b is being multiplied by these two terms. We know that because we multiplied it by q when we cross multiplied, and it was already being multiplied by r. So if we want to isolate it, we would divide by the other two
Very cool, Connie.
letters that are being multiplied by it. So that would give us b squared equals 2mv over r squared q.
So let me just use
And then you square root it
Like,
because it's
do you
squared.
take the r out or like?
So if what you're square rooting has anything in there that could be square rooted, you would simplify them. If not, you don't have to. So can 2 be square rooted?
No.
Okay. Can m be square rooted?
No.
Can v be square rooted?
No.
Okay, so all of this is still in the square root. Can r squared be square rooted?
Yes.
So that is going to come out of the square root. Can q be square rooted?
Oh.
No.
Sometimes.
Now this is kind of strange.
That's
Ew.
nasty.
And so we would probably
It's
write
so
it.
cool.
We would probably put it
Like R and then
like
square root.
this. But honestly, there's not really like a pretty way to
Does
write
it
it.
matter?
Can we just keep it?
Does it matter? It matters that you simplify it.
So we can just.
And it matters that you don't have a complex fraction, so you don't want a fraction on top of a fraction, but otherwise, as long as you're not like violating those rules, it doesn't really matter.
It's literal
Can we use
nastiness.
the one with the R squared cube rather than making it into a fraction?
As long as this is simplified, anything that's simplified is simplified, and it's not a complex fraction, you can leave it.
R square root cube.
This top one.
Well, it's not r times the square root, it's 1 over r, because it was in the denominator.
So we have to simplify it to
Yeah, because it's
Listen.
not, this was not part of the numerator, so therefore it can't be this, because that's saying it's in the numerator. It has to either be 1 over r, or it has to be in the denominator of that fraction. Make sure you put the plus or minus, and then also, if it's a question that has multiple fractions, make sure you don't have something weird like, I don't know, like this. Don't do that. Because that technically is like the same as this, but it's not simplified. Remember, we spent an entire section simplifying complex fractions. If you put a complex fraction on this test, I'm going to be very upset. Because then I'm going to know that you did not understand the purpose of this, which is simplifying, simplifying, simplifying. So we have to know how to simplify this stuff so that when you get into further math classes, you can do that math. Right now, it seems like kind of pointless, because it mostly is. But it's necessary to do higher level mathematics. Also, like, this could be helpful in a physics class if you're solving for mass instead of volume. I mean, this particular formula is really easy, but there are situations where, like, you know, Fahrenheit and Celsius, we did that at the very beginning of the year because that was linear.
Yeah,
Being
no.
able to go from Fahrenheit formula to Celsius formula, like the conversion formulas, is a helpful skill. Like, that's how Google knows what the temperature is. If you ever type in, like, 32 degrees Fahrenheit to Celsius, Google is doing the formula in its little Google head.